Good day, everybody. This is Dr. Nandi. I'm back again. Today, I'm going to show you how to use Statkey, which is a free software available on the internet to generate a 96% confidence interval for the mean with 1,000 samples. We will use an existing data in stat file. You can also, in Statkey, or you can also use your own data file. Okay. So without further ado, I will share my screen with you. Okay, let me find that screen. Okay, so this is the screen, Statkey. It is the web address is www.logs5stat.com. And if you search like that in the web, you will find it. And now we generate. So there is an existing data already in the data file. I told you about that. And this is the data table. These are Mustang, I suppose, Mustang cars in thousands of dollars prices. And we will work with that existing data. Okay. So for the original sample size is 25, mean is 15.98 thousand. The last three zeros are taken away. Median is 11.9 thousand, and the standard deviation of the sample is 11.114 in thousands, of course. So now we are going to do a Bootstrap. So we will generate 1,000 samples. Okay, so we go and click. Okay, so this is your original sample from which you are generating 1,000 samples. Okay, by computer simulation. That's what the computer is doing basically. The software Statkey is generating. Now in that sample, size is 1,000, mean is 15.978, and standard error. Standard error is the standard deviation of the population, which we had 11.114 divided by square root of the sample size. So standard error is the standard deviation of the sampling distribution. With this information, we can easily calculate the mean, the confidence interval for the population mean, because we know the mean of the sample, okay, mu x bar is 15.978 plus margin of error will give you the upper end of the interval, and mean of 15.978 minus the margin of error will give you the lower bound of the confidence interval. Now let's talk about a simple case where the confidence interval is confidence level is 95%. In that case, margin of error is equal to z alpha by 2, or the critical value of z multiplied by the standard error. You already see the standard error is 2.197. So let's assume z alpha by 2 for, not assume, let's assume the confidence level, C level is 0.95. In that case, the alpha, which is level of significance, which is complement of confidence level, is 1 minus 0.95, is 0.05. Alpha is called level of significance, it's 1 minus C, it's 0.05. And that will be the area in two tails. Okay, so area in each tail will be 0.025. So now if I go to my calculator, TI-84, so this is my calculator, TI-84. I put it on, and then I do second, press the second button on the top left corner, then verse in the third row, then number 3, which is in norm. Okay, and my area in the left tail is 0.025. Why? Because alpha itself is 1 minus C is 0.05, and area in each tail is alpha by 2, which is 0.05 divided by 2, 0.025. My mean is 0 because it's a standard normal curve. Standard deviation is 1. I do not touch those. I go to paste and hit enter twice, not once, twice, remember twice. Okay, and you will get the critical value of Z is minus 1.96 in the left, and on the right tail by symmetry, it will be 1.96. Now you take this critical value of Z, which is 1.96, and multiply with the standard error. Okay, so critical value of Z, which you got from the calculator for 95% confidence interval, which is 1.96 times standard error of 2.197. Will give you the margin of error of 4.306. So 1.96 is the critical value of Z for level of confidence 95%, alpha value of 0.05, C level is 0.95, Z alpha by 2 is 1.96 times standard error of 2.197 gives you the margin of error as 4.306, which you might say 4.306. Let's keep it at 4.306. So what is the lower bound of the 95% confidence interval? It will be the mean of the sample, which is 15.978 minus, okay, minus the margin of error, which you calculated is 4.306. So the lower bound is 11.672 and the upper bound is the mean, sample mean 15.978 plus 4.306, which is your margin of error, which is, again, to remind you, is a critical value of Z times the standard error. So the upper bound of the confidence level is 20.28. This is the 95% confidence interval from this data set that I just generated. So what is the bottom line? The bottom line is with 95% confidence, we can state that the actual population mean will be between 11.672 and 20.284. Of course, these numbers are in thousands because this is the price of a car. Okay. If you have any question, please write me a comment and I'll get back to you. And also please subscribe to my channel, and because I come back every week to do a new problem in statistics. Thank you. Thanks for watching my presentation. And if you have any question, please write me a comment. I'll reply immediately. And please do not forget to hit the subscribe button at the bottom right corner. Take care and have a nice day. I'll see you next time.